Problem 16 in our review of probability. According to a research institution, men spent on average $134.97 on Valentine's Day gifts in 2009. Assume the standard deviation for this population is $45 and that this population is normally distributed. A random sample of 15 men who celebrate Valentine's Day were selected. All right, and they want you to complete parts A through E. So to begin with, let's consider the standard error. So note the population is normally distributed with a mean and standard deviation as given. Now the sampling distribution of X bar is normal because the population was normally distributed. So any size sample is going to result in a sample mean that's normal. So we don't need n to be larger than 30. The mean of the sampling distribution would be the same as the mean of the population, but the standard deviation of the sample mean, the standard error, would be the standard deviation of the population, sigma, which is 45, divided by the square root of the sample size, which is 15. So let's calculate that real quick. So if we take the standard deviation, which is 45, and we're going to divide that by the square root of the sample size, which is 15. Here, that might be a little bit difficult for you to see right now. So let me resize that just a little bit. So to 2 decimal places, the standard deviation or the standard error is going to be 11.62. So that'd be $11.62. So I'm going to use this now as my standard deviation for the sampling distribution for X bar, which will be used in calculating the probabilities down here for the sample mean being less than or greater than. So for part B, what is the probability that the sample mean will be less than 130? So in StatCrunch, I'm going to get my calculator out for the normal distribution. And so we said that we're looking at something that's normally distributed with the mean the same as the mean of the population. So that's 134.97. Now the standard deviation is the standard deviation of the sample means, which we just calculated to be 11.62. So now we're ready to make some calculations. I'm just going to resize this window a little bit. The first, we're looking for the probability that the mean, sample mean, is less than 130. So less than 130. Press compute, and I get to 2 decimal places, 4 decimal places, 0.3344. What is the probability that the sample mean, X bar, will be more than 145? So I'll just change this to greater than 145. Compute. And so to 4 decimal places, that's 0.1940. So 0.194. Letter D, what is the probability that the sample mean will be between 115 and 160? So to find the area between two values, I'll choose the between option up here. And I want to be between 115 and 160. So compute that. So between 115 and 160, there's a probability of 0.9415. Now in part E, it says identify the symmetrical interval that includes 95% of the sample means if the true population mean is 134.97, with the standard deviation, of course, we've calculated to be 11.62. So here, I want the area between two values going the same distance left and right of the center. And so what I want to do is trap the middle 95%, which it will do if I'll just say the area between two values is 0.95. So if you'll notice when I type in 0.95 on the right-hand side of the equation, these two values are left blank. It will calculate those two values and center that area, that probability about the mean 134.97. So in this case, it says round to the nearest dollar as needed. So rounding this to the nearest dollar is 112. Then over here, rounding to the nearest dollar is 158. So approximately 95% of all the sample means that we should witness in samples of size 15 should fall between 112 and 158. So here we've looked at using the sampling distribution of X bar to calculate some probabilities based upon the normality of X bar. So this coincides also with our discussions of the central limit theorem. So I hope this has been helpful.